because today is pretty easy if you know what we did yesterday. So let's take a quick look at that. Did I ask you guys to do which one? Okay. Now, the one you should have had trouble on is the one where they had the dice. We had to throw 2 dice. Everybody do that, at least? All right. Yeah, number 11. So we're going to talk about that for a second, too. But let's go ahead and tell me what you got for on the second worksheet. Everybody go to the second worksheet, please. Somebody tell me what the probability of getting a 15 is.
6.25.
As a fraction, though, guys.
1 over 16.
1 over 16. And then as a percent? 6.25%. Now give yourself a check if you got that right. What's the probability of getting an even number? Which is what fraction? Which is what fraction? 1/2, which is 50%. All right, what if we're greater than 10? Which is what fraction? 3 over 8. Good. Wow, Ms. Bragdon, thank you so much. Very good work. All right, this is where you guys were asking me about perfect square. How many perfect squares are there?
So there's 4.
4. Because 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, and 16 is a perfect square. So that reduced is what? 1/4, which is, all right, I'm happy with you guys. All right. Now, over here, again, the important ones. What's the probability of getting a pink? Somebody. 9 out of how many? 9 out of 40, which is?
22.5%.
Okay, what's the probability that you're orange? We're going to skip to number 7. What's the probability? 1 over 5, which is 20%. What's the probability that you're not purple?
1.
Sorry, guys. What about 11? Probability that you're blue? 0. 0%. Everybody good? I don't care if you wrote 0. That's it. And what's the probability that you're not orange? 4/5. 80%. Is everybody in agreement with that? Miss Caroline? Oh, they're right? Okay, thank you. All right, what's the probability of getting a, what's the probability of getting a 3 or a 5? But the original fraction was what? 26 over how many? Does everybody agree with that? Is that right? 26 out of 80? And that reduced to what? Which is what percent? All right, I'm pretty happy with you guys. Okay, prime. Is the number 1 prime? We talked about this.
No.
No. Is 2?
Yes.
Is 3?
Yes.
Is 5?
Yes.
7?
Yes.
The only even that's prime is what?
2.
All right, so we're in good shape. So how many of them are prime?
4.
No. How many? 43 out of how many? How does she get 43? Thank you very much. Exactly correct. You added up the frequency, but somebody said it should be? Somebody said 45. Uh-oh. Big mistake. First mistake of the day. Great job. 45 out of 80, which reduces to what? 9 over 16. Which is the same as 56.25%. Uh-oh. What's the probability that you're not a 4 or a 7? 61 out of 80. Which is the same as what percent? 76 point. All right. Now again, remember guys, it's not so much, you're just supposed to be checking your work. Now what you're doing is you're seeing, wow, I understand it kind of or I don't. So if you're not sure, you gotta let me know. Anybody have any questions? All right. Now, what I want to do now is the next one's kind of the same, except for number 11. So I want to check out number 11 with you, and I want to show you something. All right. And here's what I need for you to do. All right. It says, suppose two number cubes are rolled. Find the probability of rolling the sum greater than 8. Well, most kids don't even know how many possibilities are there when you throw the dice. How many possible outcomes? Somebody tell me. There are 36. How did he know it was 36? Because he looked up there on the board. It's all the number 36 in the denominator, which is the total. Right? But more importantly, here's what I want to show you guys. All right? That right there represents all the possibilities. Now, please look up on the board so I can try to show you it's not hard. It looks hard, but it's not. All right? When you throw the dice, what's the lowest number you can get when you throw 2 dice? 2, I'm thinking, isn't it? If you get a what? If you get a 1 and a 1. Then the next one would be a what? And then. All right, does everybody see I'm just listing out all the possibilities? Then I could get a what? 2, 1. Now, does everybody understand that? And of course, I can continue the pattern 3, 1, 3, 2, all the way to 3, 6, 4, 1 to 4, 6, 5, 1 to 5, 6, 6, 1 to 6, 6. Everybody agree with that? And then we would do what? We would just count how many there are. And it's a 6 by 6, so that makes a total of what? 36. Now, the reason I put this line diagonally is because when you're throwing dice, 2 dice, some people say 7 is lucky. Now, it's not that 7 is lucky, it's just 7 occurs more frequently than the others. All right, so let's take a look at that. Does everybody agree that 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6 all add up to 7? Yeah. So look, 1, 2, 3, 4, 5. There are 6 possibilities for making a 7. Everybody hear me? Mm-hmm. There are 5 possibilities for making a what? 6. There are 4 possibilities, 3 possibilities, 2 possibilities, and 1 possibility. So what I'm just demonstrating right now is I'm just trying to show you how math is patterns. Exactly correct. And then you go 8, 9, 10, 11, 12, and then the pattern goes from 1 to 6, and then back down to what? 1. Everybody see that? So if somebody said, what's the probability of getting a 3, you should be able to tell them rather quickly that it's 2 out of what? 36. And why is it 2 out of 36? Because the lowest number is what? 2. And that occurs how many times? Once. Then a 3 would occur what? A 4 would occur. And then you just count all the way up until you get to 6. And then you back it down to what? 1. Now, I would want you to be able to reproduce that. How many people think they could reproduce this little chart right there? That's not that hard, right? It's not that hard. All right. So if I were to give you a question like this, now I want to read the question to you to make sure. It says, find the probability of rolling a sum greater than 8. So when you throw the dice, what numbers are greater than 8? 9, 10, 11, and 12. 9, 10, and 11, and 12 are. Well, if we look at our chart right here, that information is right here. Does everybody see that? It is. It is. And so how many of them are there? 4 plus 3 plus 2 plus 1. And that would be what? 10. Does everybody agree? So we would say that was 10 out of how many? 36, which reduced to, which is the same as about 27.8%. All right, now listen. I think that was about as hard as it can get. Everybody agreed the other stuff was kind of easy, but that was kind of tricky. The reason it was kind of tricky is because you had to label or you had to draw out that table there. Is everybody good with that? Or does anybody have any questions? All right. Again, guys, that's really kind of important. All right. Now, what I want to do is I want to now open up 10.7. So everybody pull up 10.7 from classroom and we'll get started with today's lesson. Come on, 10.7, pull it up. Okay. Now, here's what I want. All right. I want someone to tell me what they think theoretical probability is. What do you think?
Theoretical, that's theory.
That's exactly
And
right.
probability is the chance of something. So I would say estimating the chance of something.
Exactly. You said it perfectly. So theoretical probability, what's a theoretical probability when you flip a coin?
50-50.
50-50. Or we say that we know, based on theory, that the probability of getting ahead would be 1 out of 2. Everybody with me? Now let's say I tell you take out a coin and flip it 50 times. And 30 times it comes up heads, and 20 times it comes up tails. The theoretical probability of getting ahead would be 3/5, because we flipped it 50 times. And the theoretical probability, or the experimental probability, would be 2 out of 5. Hold up, guys. Listen, is everybody hearing me? All right, he said it perfectly. When you do conduct an experiment, sometimes you're just going to count the number of times you get ahead. In the long run, the fraction should work out to be what? 1/2. But in the short run, it might not exactly be 1/2. Is everybody with me? Same thing when you throw the dice. If you get a 1, and you throw it again and you get a 1, does that mean that 100% of the time you're going to get a 1? No. That was just the what? The experimental probability. Everybody hear me? All right? So again, the theory of getting a 1 would be 1 out of 6. The experimental probability is you conducting an experiment to see what the probability is. All right? Over a sample. All right? And what's the sample? Just the number of times that you do it. All right? So let's see if I can explain things adequately. All right? So here we go. It says, the table shows the results of an experiment in which a spinner was spun 50 times. Find the experimental probability for each outcome. Now, how many numbers are on the spinner here? So to me, it would assume that it's going to be 1 out of 16 for each number. Do you agree?
Yes, sir.
That would be the what? Theoretical. But maybe one space is larger than the other, correct?
So then you have to add it.
So what I want to know now is what, based off of your data, what is the probability that you get a number less than 7? Well, how many times did we spin? 50, so that's the denominator. Now, how many of the numbers are less than 7? 6 of them, right? So we're going to add up this column right here. Can somebody add that up for me? I think I got, is that right?
Yeah, 22.
22. So we got 22. 22 out of 50. All right. So now we would just go ahead and reduce that to what? 11 out of 25. Guys, if you understood yesterday, today is guess what? Easy also. All right, it's very easy. So let's take a look at number 2. What's the probability of getting it even? Well, it seems like it should be what? 1/2, right? But we don't know that. So let's figure that out. So, again, still the denominator is going to be what? 50. Now, how many times did we get it even? I want somebody to, or you guys. How many? Somebody said there were only 8 evens. Is that true? No, because why, Julia? Because you have to add up the number of times that evens. Somebody said 31.
Yeah, I got 31.
Anybody else get 31? So we'd say the probability of getting it even would be 31 out of 50. Now, if you need to borrow a calculator, you can, but I think some of you guys are starting out to bring your calculator every day, which is a good idea. Julie, do you have your calculator?
Oh, yeah.
No.
I have one right here.
Perfect. All right, perfect. Don't, hey, listen, all you have to do is address me. That's it. Ignore all the other stuff. Because I'm the one helping you with your grade. No one else. Okay, so if 31 out of 50 are even, how many are not even?
19.
Did everybody see how you should be doing that? You should. Hopefully, you didn't count up the ones that were not even, right? So again, that should have been what? 19 out of 50. All right. Now for number 4, what's the probability of getting a 13? 1 out of 50. What's the probability of getting a number greater than 12?
11.
Anybody else come up with 11? Everybody happy with 11? All right, 11 out of 50. Okay, and what's the probability that we are prime? It's 1 prime. No, we already said that, so make sure you remember that for your test because I'm not going to tell you. All right, so here we go. Prime numbers, 2 is 3, is 4, 5, 6, 7, 9, 11, 13, and that's it, correct? All right, so we identified the prime numbers, correct? Who keeps saying 14? Just, you're not with me. You understand me? All right, that's the problem I'm having. Answer my question. All right, now how many prime numbers are there? 14 out of how many? But of course, we're not going to leave it like that. 7 out of 25. So those are the what? Those are the experimental probabilities. Because why? Because that's what we did to figure out what the probability could be. If you do it enough times, is 50 a big enough sample? Maybe, maybe not. All right, there seems to be a lot of numbers, so I'm not sure 50 would be good. All right, is everybody with me on that? All right, but based on those numbers, we could then predict what the probability is for any number. All right? So let's take a look at what they say for question number 7. All right? It says, the table shows the results of a survey of how many? 300. So we don't have to add them up, right? So we know the total down here would be 300. All right? So it says, out of a similar group of what though? 500. So now we're going to make a prediction based off of our data. So this is kind of the new thing that I want to make sure you understand, which I'm sure you do. All right. How many chose cooking 101? 47 out of how many? Right. So here's what we need to do. We need to do 47 out of 300, right? And now we're going to base a prediction based off of how many people now? 500, not 300. You're right. This is what it is out of 300, but I want it out of what? So I got to make an equivalent or a proportion and say, well, if there's 47 out of 300, then what would it be for 500? All right. So now, does everybody remember how to solve this proportion? We just do what? Cross multiply and divide. So we would say 300x is equal to, wait a minute, 235 or 23,500. Does everybody agree with that?
Yeah.
I'm writing the equation. And then from there, you divide by 300. And when you divide by 300, we could say, or we would just say what? 78, right? Now, we're not going to say 78.3 people, although I wouldn't mark it wrong. Right? We're talking about a person. We don't want to cut somebody in half. We're saying it's a fraction of a person. All right? Now, again, I don't think that's that difficult. All right? Anybody have any issues setting up that proportion? All right, so now let's take a look at the next one. Let's see if you're with me. It says, how many would choose band as their favorite elective? Well, how many chose band? Out of how many?
300.
So again, it's the same principle, 66 out of 300. X over 500. Now remember, I need you to write down that proportion for me. Write down that proportion. Actually, she's correct. Like right now, we could just reduce this by 3. Look what she's saying. I think this is what she's saying. If I reduce that by 3, that would be 22 over 100, right?
Yes.
But then you could just multiply that by 5, right? So that would be 110. All right, that's how I would help you with understanding that. All right. Now, I'm not necessarily saying that's the right way for everybody, because if you wanted to, you could just say, when you cross multiply, 300x is equal to and then when you divide, you would see that x is equal to 110. Everybody see it doesn't really matter how you set it up. All right, everybody good? All right. Robotics. How many are robotics? Right, so we're going to go 16 out of 300 again. X over 500. So, wow, Julia, tell me again. Approximately, is it? Yeah. So, wouldn't we, if it was 26.6, we should just go ahead and make it, yeah, I would prefer you just say it's 27. Is everybody okay with that? And like I said, if you put 26.6, I don't. The important part is you know how to set things up. That's why I'm telling you it's important to set those up. All right. Number 10. It says, how many more teens would prefer art to computer science? Now, art to computer science would be what? Very nice. So it'd be 28 over
300.
Exactly, guys. Very good. So we would say 28 over 300 is equal to x over 500. And so that would be about how many? About 46 or 47? So we'd say 47. Good job. I told you I don't think this is that hard. All right. Now let's read the next situation. It says, how many people are surveyed? No. Of the 200 adults surveyed. So there's 200 total, right? 85 said they were planning to go on vacation. So pretty much it would have been 85 out of what? 85 out of 200. So it says, what is the experimental probability that an adult was planning to go on vacation over spring break? We would just say what? 85 over 200, and then of course I'd have you to reduce that. 17 over what? 17 over 40. Everybody happy with that explanation? No, nothing too hard. Now it says suppose 250 adults were surveyed. So now how do I set that up?
You do 85 over 200 equals x over 250.
Exactly right. Now if you wanted to, could he have chosen the 17 over 40?
Yes, he could have.
Yeah. You could use that because they're equal fractions. All right? They're equal fractions. So now when you cross multiply, what is the equation, Max?
X is 160.
Well, I know, but 200x.
Oh, 200x.
What is 85 times 250?
Oh, 85 times. Oh, okay. It's 21,000, yes.
How much? 250? All right. And so x is then would be approximately what? 106.25, or we'll just say what? About 106. Everybody agree that's not that bad? All right, so let's look at 13. It says a coin is tossed 30 times, and it comes up heads 18. So is that pretty good? Yeah, because it should have come up what? 15, so it's not that far off. Right? Find the experimental probability of tossing heads. So it would be what? 18 out of 30, which reduces to 3/5. All right. Now, obviously, that's more than 1/2, right? So they say compare the experimental probability with the theoretical probability. You could just say that the experimental probability is greater than the what?
Theoretical probability.
It's greater than the theoretical probability because the theoretical probability would be what fraction?
1/2.
It should be 1/2. Everybody see that? The theoretical probability would be 1/2, but the experimental probability came out to be what? 3/5. So the experiment proved to be greater than the theoretical. Everybody happy with that? All right. Yep. I don't think they're that hard. All right. What I want you to do is I want you to do this worksheet here, and then try a couple. Well, I'm not trying a couple. You don't have to do number 6. Or 4. Just do the 1, 2, 3, and 5 on the ERB stuff. Everybody hear me? Second worksheet, and then 1, 2, 3, and 5. Anybody have any doubts? Any questions? All right, good job for today. Try to get it finished. What time's the bell ring? So we have like 6 minutes.